Hey everyone, and welcome to our video on greatest common factor, otherwise known as GCF. We just got done doing LCMs. GCF, greatest common factor, is a little bit different. So before we start the actual note sheet that you have, we're going to just do a little warm up here. Again, this is probably something you've seen in your math past. So I'm going to review some real basics here. Say you had the numbers 45 and 50, and you wanted to find the greatest common factor. Well, I'm going to tell you, now that you're in high school, the easiest way to do this, honestly, especially if you're good with your times tables, is to ask yourself this question. What is the biggest number that goes into both 45 and 50? Like, a lot of people can just do that. Like, oh, 45 and 50. Okay, what's the biggest number that divides into both of these? In other words, what number divides into both 45 and 50? And if there's more than one, you want the biggest. So like, I can just look at that and know that it's 5. The biggest number that goes into 45 and 50 is 5 because I just know it, because I know my division, I know my times tables. If that isn't easy for you, if that's a struggle and you're not sure, this method that I'm going to show you takes a little bit longer, but it will get you to the same answer. So this is what you do. You break down the 45 and the 50 into its prime factors. And some of you have done this on Alex. So what you do is you ask yourself, what two numbers multiply to give me 45? Well, you have a couple options. You could do 9 times 5, you could do 15 times 3, and it really doesn't matter because in the end, when you get all the way down to the prime factors, it'll end up the same. So I'm just going to choose 9 and 5 because that's the first thing that comes to my head. Now 5's prime, so I'm going to highlight that as being done. And by prime, if we want to review that, it just means that you can't break that down any further. In other words, the only factors of 5 are 5 and 1, and so that makes it prime. But 9 will certainly go further into 3 times 3, and both of those are prime because the only thing we can break a 3 down to is 3 times 1. So written as a product of prime factors, we can write 45 as 3 times 3 times 5. Product. And you can see, there it is. 3 times 3 is 9. 9 times 5, whoop, back to 45. Okay, 50. Again, a couple options. We could do 10 and 5. We could do 25 and 2. I'll just go ahead and do 25 and 2. And 2 is prime, so we'll highlight that. 25 will go further, of course, into 5 and 5. And those are both prime, so I'll highlight those. So 50, written as a product of prime factors, if I go from least to greatest, would be 2 times 5 times 5. 2 times 5 is 10, 10 times 5 is 50. So there we have that. Now, what you want to do to find your answer, GCF, greatest common, let's remember that, common factor. Well, here's the deal. These are the factors right here. So we've got like the F in the greatest common factor. So now we want to pick what they have in common and the biggest amount of factors they have in common. So if you look here and you look here, you can see that the only thing they have in common is this 1 5. Even though the 50 has another 5, this one doesn't, so they don't have a second 5 in common. So there it is, 5, the biggest number that will divide into both 45 and 50. Okay, very cool. So the answer to this is 5. Now let's go down and add some variables. Same two coefficients, 45 and 50, but now I have some variables. Well, it's no big deal. You just break it down to its factors and you do the same thing. Now, just a side note, and I did this on the LCM video as well, there is a way in your TI-84 to find a greatest common factor. So if you remember from the last video, if you press the math key, which is right here underneath alpha, so math, arrow over to num, and come on down here, not to number 8, that's LCM, but to number 9. Let me bring this up a little higher. Number 9, you're going to see says grade GCD. Well, in the TI-84, that is the same as GCF, so don't let that D throw you off. So hit enter, and my two numbers were 45, 50. Hit enter, and there it is, 5. So that's maybe a quicker way to get there. I don't want you to be totally reliant on the TI-84, but it does have this feature, so just know that it's there. So that is that. And now what I'm going to do is I already know my 45 is 3 times 3 times 5 from up above, but I'm going to keep going. X to the 4th means X times X times X times X, and Y is Y, I'm sorry, Y to the 3rd is Y times Y times Y. So there is the first monomial broken all the way down. Now 50, we already know, is 2 times 5 times 5. And then we have 6 x's. 1, 2, 3, 4, 5, 6, and then 2 y's. So that's that monomial broken all the way down. So now all we have to do is circle what they have in common. So we already know they have a 5 because we did that up above. So we'll circle a 5. Okay, now how many x's do they have in common? Well, think about this. They can only have in common the least amount of x's in any one term, right? So this monomial over here has 1, 2, 3, 4 x's. This has 6. So they can only have at most 4 in common. So the idea is, guys, when you're doing a greatest common factor, you actually end up taking the lower of the two exponents because the lowest amount is the most these two can have in common. So that's sort of a shortcut, if you will. If you don't want to write these all out, you just say, well, this has 4 and this has 6. So at most, they have 4 in common. Okay, and as for the y's, this has 3 y's. This monomial has 2. So how many can I circle from both at the same time in common? 2 and 2. See, I can't circle that y because there's not a y to circle over here. So the GCF of this problem is 5x to the 4th, because you've got 4 here, 4 here, y to the 2nd, 2 and 2. Final answer. So if you want to go a little bit faster, you have this capability, plus you know to take the lower of the two exponents on any variable. It's kind of funny because the word greatest is in the title, yet you take the lower exponent. It's like that's opposites. Greatest, lower exponent. Okay, so let's turn this over and finish up our note sheet. It will go really fast now. Okay, so it says here, you can easily find the numeric part of a greatest common factor on your TI-84 by following these steps. I've already shown you those steps, so let's move on. I've also already spoken to this. To find the variable part of your greatest common factor, just take the lowest exponent on each variable. So here we go. Find the greatest common factor 4. So I've got a 10 and a 2. So one way you can do this, go to your calculator, math, num, 9, 10, 2, boom, and I'm getting a 2. Or you can ask yourself my question, what is the biggest number that divides into both 2 and 10? Well, 2 divides into 2, and 2 divides into 10. So the numeric part is 2. Now let's look at our exponents. We've got x to the 6th versus x squared. Well, I'm going to take the lower x because the most they have in common is 2. You can't take 6 from a term that only has 2. So x to the second. And look at my y's. They definitely have just one y in common. And that is my GCF. On to example 2. Find the greatest common factor, 40 and 5. Well, the biggest number that divides into both 5 and 40 is 5. And let's compare our y's. We've got 4 versus 2. The lower is 2, so they have 2 in common. See how quickly it goes? And last but not least, greatest common factor for a 6 and a 45. So you got to ask yourself, what's the biggest number that divides into both 6 and 45? Well, 6, no, because 6 doesn't go into 45. 3 goes into 6. Does 3 go into 45? Yes, it does. 15 times. But if you're not sure, you can always do math num 9. What were they again? 6 and 45. 6 and 45. Boom, 3. Okay, so 3. Now let's compare the A's. This guy has an A, and this guy doesn't have any. So they have no A's in common. So I cannot put an A in my common factor. Look at your B's. 1 versus 3. How many do they have in common? Well, I have to take the smaller. They only have 1 in common. So my GCF here will be 3B. And that's all she wrote. Greatest common factor. Hope you understand it. Thanks for watching.